work energy and power. Yes, students, here in this chapter junior inter physics, 3 long questions are there, 1 question guarantee. So in that 3 questions explained, questions are in playlist. Let's go to the playlist and practice it. You'll get the 8 marks question. Alright. Yes, students, so what is the question here? State and prove law of conservation of energy in case of freely falling body. The object is released from certain height, then we have to verify at any case the energy remains same. What is the statement here? Energy can neither be created nor be destroyed, but it can be converted from one form to another form. The total energy of the closed system always remains constant. This is the statement. Pause the video and copy the statement if you don't have material. Right. So here we'll prove this statement in this case. Here proof. What we have to prove here in case of freely falling body. In case మనం ఒక ఆబ్జెక్ట్ ని సర్టెన్ హైట్ నుంచి వదిలేస్తే ఎలాగా ఇలాగా ఓకే సో దిస్ ఇస్ ద ఆబ్జెక్ట్ ఆఫ్ మాస్ m. It is released from certain height. This is the ground, certain height at a point a, right? So here after some time it reach point b, then after some time it reaches the ground. This is the position c before reaching the ground. Here we have to verify the energies of the body at point a. So body of mass m, it is at certain height h. This is the certain height capital H, and the body velocity at a is initial velocity u is equals to 0. Here it is the maximum height h. So to do this problem we need 2 formulas, potential energy formula and kinetic energy formula. Potential energy P is equals to mgh. Kinetic energy formula half mv square. So at a you observe the total vertical motion. What is potential energy? Potential energy is equals to, the formula is mgh. So the h is height is capital H we have taken. The next one is kinetic energy. Kinetic energy Ke is equals to half mv square. But here the velocity is initial velocity, body is at rest, so we have to take it as 0. Half mv square. So velocity at a, we have to take velocity at a, va 0. So velocity at a, initial velocity is 0. So that's why we have to take here 0. So 0 square, finally 0 into anything 0. So we got total kinetic energy is 0 at point a. So only there is potential energy. We have to prove the total energy, that is nothing but mechanical energy. Mechanical energy me is equals to kinetic energy plus potential energy, or potential energy plus kinetic energy. Kinetic energy is 0, potential energy is mgh. So totally mechanical energy is mgh. This is the total energy. Sometimes it represented like capital U, right? So what is the energy of the object? Energy of the object at a is mgh, right? So once copy this, pause the video and copy the relation. Next we go for point a, right? So here at point b, next at point b the object traveled certain distance. Let the distance be x, and the remaining height, how much remaining height? Total height is h, out of h the remaining height. For example for understanding purpose, total height is 100 meters, so it was traveled 40 meters, then remaining height how much? Out of 100, 40, the remaining height 60. How we got 100 minus 40? So we have to subtract 40 from the total height. So like that here also we have to subtract 40 or x value from the total height. Total height is h minus traveled height is x. So this is the height. The object is at h minus x at point B. Right, students. So now we'll find the potential energy and the kinetic energy. Potential energy is equals to mgh. Mass remains constant, mass always same, g always same, but height is different at point B. Height is different. What is the height? Height is h minus x. The next, kinetic energy. Kinetic energy is equals to half mv square. V means velocity at B. So what is the velocity at B? Velocity at B means this is under acceleration. So that's why we have to use equations of motion here. We have the formula v square minus u square is equals to 2as. Here final velocity v, initial velocity u. It was started from rest, freely falling body. So initial velocity 0. Well, final velocity means at vb square minus this is 0 square is equals to 2a means g, acceleration is g. Next displacement is x. So finally we get vb square is equals to 2gx. Okay, so you can substitute here kinetic energy. Formula is half mv square, but velocity means at point B, velocity is vb. So here also we got vb square. Here vb square is there. Substitute vb square value. Half m vb square. Vb square means we can write 2gx. 2gx. So 2 will be cancelled. Kinetic energy is mgx. Next, total energy or mechanical energy. Mechanical energy is nothing but it is the sum of potential energy and kinetic energy. Potential energy plus kinetic energy. So potential energy means mgh. So we have to multiply this one inside. Then you will get mg capital H minus mg small x. And this is about total potential energy. Here kinetic energy formula is plus mgx. Mgx will be cancelled, positive, negative. So finally mechanical energy is mgh only, right? Mechanical energy here also mgh. Mechanical energy remains constant, mgh. At point A also mgh, at point B also mgh. Okay, we hope you understood. Pause the video and copy it. Next, at point C. At point C, what is the velocity? What is the height? Let us see. So at point C, the velocity object traveled from A to B and B to C at a time. So final velocity at C, velocity is Vc. Height is 0. Height is 0 before touching the ground. Height is 0. Let it be considered as height is 0. So here simply we can do it. Potential energy mgh formula mgh common h height is 0. So total potential energy is 0 because of height is 0. The next kinetic energy k is equals to formula is half mv square, but object position is at C point. So vc square we have to write. Again we have to find the velocity, final velocity at point C. Right. So what is the formula again? V square minus u square is equals to 2as. The equations of motion, third equation. Final velocity means at Vc minus initial velocity 0, 2, a means acceleration, g, s means distance traveled. How much distance traveled? Total height, it is taken as capital H. So finally, Vc square is equals to 2gh. Yes, students? Right. So instead of Vc square, we can substitute 2gh. Then you will get the total kinetic energy. Kinetic energy of m into Vc square means we can write 2gh. 2 will be cancelled. Mass mg capital H. So what did you observe? Kinetic energy already total we received in the kinetic energy total mgh only. Then potential energy is 0. So here also we have to check the mechanical energy or total energy. Total energy is nothing but potential energy plus kinetic energy. Potential energy is 0, kinetic energy is mgh. So finally, here also mechanical energy is nothing but mg capital H only. So at any point A, point B, point C, the total energy remains constant, but what we can observe at point A, total energy is in the form of potential energy. At C, total energy is in the form of kinetic energy, but at B, total energy it is in the form of potential energy and kinetic energy. Why? Because at point B there is height and there is velocity also. Okay, so this is the proof verification. What is the proof? At A, at B, at C, total energy, mechanical energy is remains constant. Okay, pause the video and copy it. I hope you understood.